Thanks, everyone. Thank you so much for joining us for our next session, where we will have Mike McCabe joining us. Mike is the president of Cloud Security Partners, where he helps clients with their cloud security challenges. Welcome, Mike.
Thanks. Thanks for the intro.
Of course, and you'll have the stage.
Great. Thank you. Oops. Well, thanks for the intro, and I want to thank the conference for conference group for holding the conference, and thanks for letting me speak. This is a topic that I'm passionate about, so I'm happy to rant at some people remotely about infrastructure as code. So the topic is infrastructure as remote code execution. I'll be diving into kind of what I mean by that and the ways that's applicable. A little bit about me. As Elizabeth said, I'm Michael McCabe, president of Cloud Security Partners. We at Cloud Security Partners help clients, big and small, through their cloud security challenges, their cloud security migrations. A lot of people are moving from on-prem or data centers into the cloud, and that presents a whole bunch of cloud security challenges. And so we've been working with clients for the past 7 years to help make that migration and make those challenges easier. And I am weirdly passionate about infrastructure as code. This is something that I've been focusing on a lot the past few years with clients, and I'm passionate because it's a really great way to tackle some security in the clouds. That's why I like talking about it and introducing the pluses and minuses of this technology. So we can jump into it. So what we're talking about today is Terraform. It's infrastructure as code, and there's other tooling out there. There's plenty of other different tools you can use for infrastructure as code, but this is going to be focusing on Terraform because that's where a lot of our clients are kind of focusing. So what is Terraform? It's basically codifying your infrastructure into configuration, into code, into some logic. And the goal is to move away from the old way of doing cloud infrastructure, even the way to moving away from doing on-prem or data center infrastructure, moving it to a codified and consistent way of documenting how you want infrastructure to be built, how you want it to be maintained, and even how you want it to be destroyed. So it's from a company called HashiCorp. They make a lot of great tools, both open source and commercial tools. They offer usually an open source version of most things and a commercial version. Same goes for Terraform with Terraform Cloud and Enterprise. And as they say, with Terraform you can create, modify, and destroy your infrastructure in a consistent and repeatable way. So what are some of the benefits of that? Anyone who has worked in even a small to moderate sized cloud environment knows that deploying infrastructure and having it be consistent and having it be maintained and understanding what is used for what purpose, they understand that is a challenge. Even the smallest clients that we work with, they often have issues with either the wrong infrastructure is deployed, or they don't know why something's up there, it's lived a long time, they don't have good naming conventions, they don't have good security settings. All of those things are true even at the smallest of companies. And that's doubly true for the largest companies. We've worked with quite a few large companies that have the same challenges, even though they have huge security teams trying to tackle these things and plenty of tools. So the benefits with Terraform, and when I like talking about this is because I want to push people to using it more and to using it to kind of centralize how they deploy infrastructure, codify how they deploy infrastructure, and then apply security controls to it. And as we'll see, there's plenty of issues to tackle with Terraform security beyond just the typical cloud security challenges we have. So some of those challenges that we'll kind of get into are Terraform is often, and this is true for pretty much all CI/CD, whether it's application or infrastructure CI/CD, given a high privileged role to do its job. If you think about most pipelines, they have access to push code, they have access to push infrastructure, and that's the role they have to have in order to do what they're supposed to do, which is fine, understandable, but at the same time, it becomes a great focus point for attackers to focus on your CI/CD platform, try to get those credentials, use those to pivot into other areas, and it can be, even malicious insiders can use it to do a lot of damage, and we'll kind of talk about some of those ways they can do that. And with Terraform, yes, it's mostly an infrastructure tool, so setting up servers, databases, all the different serverless resources that you can build in the cloud. But you can also use it to execute code. You can execute different configurations with it. So it's more than just infrastructure. And Terraform is a great way to gather data about an environment. I'll kind of dig into that more. But when Terraform understands, it has to understand what your environment looks like in order to do its job, and that's a great source of information for attackers. So these are some of the challenges. And there are security controls that can be put in place, but there's also ways to bypass some of those. So we'll talk about that as well. So our experience, as I said, we work with clients moving to the cloud, or clients who've been in the cloud and going through a maturity model where they've struggled to kind of get a centralized way of deploying infrastructure out. They've struggled with security, they've struggled with compliance, or just even operational things like cost and simple things like naming or tagging. So we've worked with these companies to build out what I'm talking about, which is a way to apply all these things at the infrastructure as code level. So you can write these rules to enforce security compliance and even operational things. So we've worked with companies doing that. We've written thousands of these rules across multiple clouds, GCP, AWS, and Azure, across different languages, not just Terraform, but we've done the same for different languages. Dozens and dozens of services we've helped clients utilize in a more secure fashion. And this is adopted by thousands of internal users who use infrastructure as code pipelines to deploy out their infrastructure. And I think the thing that I love touting the most, and this is something that we just recently did with a pretty large client of ours, is we looked at all of the infrastructure deployed by Terraform in their case, that was deployed out through their security checks, looked at their CSPM, their cloud security monitoring tool, and we saw 0 security findings from that deployed infrastructure. And I'm not exaggerating, that was actually true. That was a pretty awesome moment to see that, all the work we did up front, you can basically remove cloud security findings through infrastructure as code security. So it's a very powerful preventative control, and that's why I like talking about it, and that's why I want to get the word out to people that this is the way you should be securing things in your cloud. The other great thing is it can map to your internal and external controls, so you don't have to have one set of controls for infrastructure as code, or another set of controls for operational or process or monitoring controls. So to take a step back, how does Terraform work? Because when you talk about how you can abuse Terraform or how you can secure Terraform, you have to kind of understand how it works. So there's kind of three or four main pieces of Terraform to understand. So when you write Terraform, you're coding, it's really just a configuration language, but you're coding what you want your infrastructure to look like. And then Terraform will take that and do what's called a plan, where it basically looks at your current environment and it looks at what you're trying to do and determines what those changes will be. So if you're creating a new EC2 instance, for example, it's going to say, okay, does this instance already exist? Am I creating it? Am I updating it? Am I destroying it? And it'll create a plan that basically lays out all the things it's going to do before it's going to do it. It also creates dependency trees, because obviously if you want to use, say, an IAM role, that has to be in place before you can use it with an EC2, for instance. So it will create that dependency tree of what should be created when, and any issues it would have with creating that. The same is true for destroying or updating. It'll tell you if it's going to be updated or destroyed. And it gives the output of what's going to happen before you actually do it, so you can have kind of an approval process to say, this is what I wanted to do before it's done. And then, like I mentioned, it creates that dependency tree, and there's certain things that aren't known at runtime because they may not exist. You can think of it as, say, an ARN for a resource that's being created. You don't know what that ARN is until it exists, so it can't say what it is during that plan stage. And that's something that's an unknown value, and we'll kind of touch on why that's a security issue as well. And then when it comes to actually applying the changes, that's when Terraform Apply happens. It reaches out to the cloud APIs. It does the updates. It creates updates or destroys infrastructure, and then it updates what's called the Terraform state, which is basically a file that tracks the current state of that deployed infrastructure. And that's really useful for things like maintaining it over time, for understanding what the infrastructure looks like. And it has to have that in order to kind of reason between what things look like now and what things are going to look like. But Terraform state is another kind of area to focus on for security as well. So we'll touch on that. So this is a very simple example of Terraform if someone's not familiar with it. This is using AWS, using US East 1, a very simple provider config, and we're just creating an EC2 instance. AWS instance is the resource type. You specify an AMI, you specify an instance type, some tags, and that's all you need to set up an EC2. It's as simple as that. Obviously, it can be much more complex if it needs to be, but at the core, you don't need a lot to get moving with Terraform, which is great. So then when we get to the plan stage, this is what we get. So as I said, Terraform will take that code and it will turn it into a plan based on what things are going to look like once it actually is applied. So what is the current state? What are we adding? What are we changing? What are we deleting? And you can see, might be kind of hard to see, but you can see the action is create, and it shows you kind of the after values, which are what are things going to look like after. And then you also notice there's a section that's called after unknown, which we'll touch on, but that's what I mentioned about. There's certain values you don't know until they're actually created. So this is what the plan looks at a high level. Zooming in a little bit more, you can see the details of what these plans look like. So it's really a document that lays out what was done, where it was done, the resources, the configuration of the resources, and kind of the steps. Is it an update, a create, a destroy, or what's called the no operation, no changes. So as I mentioned, the Terraform state, that holds the current state of the environment. They are implementing drift detection in Terraform Enterprise and Terraform Cloud, so that's something that's going to be in line with what we do with CloudFormation drift detection. So that's definitely a good thing. You can do drift detection in other ways, but they're going to have it as a kind of mainline utility now. And Terraform state holds your configuration, so it tells you what you have deployed, but it also holds secrets, which obviously is a big issue if you have certain secrets in that Terraform state and where you store it. So here's an example of Terraform state. Again, it looks pretty similar to the plan. It's more of a static, this is what things look like now, versus here are the actions we're going to take. But you can see in this Terraform state, there's actually a private value that was created. And if you're familiar with secrets, people generally will grab these, attackers will grab these from any source they can, whether that's source code repositories or S3 buckets or pretty much anywhere they're stored. Developer laptops are a great target as well, and they'll use those to pivot into the environment. So obviously Terraform state is a file for our Terraform workspaces that we have to protect quite a bit. And depending on how you deploy out Terraform, that will depend on where that's stored. So there's different options. You can keep it locally. You can just run Terraform and have everything stored locally, which some people do in a Jenkins pipeline, and then they'll have all those files locally, which obviously can be an issue if someone is able to, run jobs on Jenkins where they can exfil that data, or if they can get a shell onto the Jenkins box and then pull off those secret values. So Terraform state is a very important file to protect. You definitely have to manage where it's kept and keep access to it very limited. So as I mentioned, secrets are stored there, and this is a well-known issue. And if you think about it, you kind of have to keep secrets in Terraform state because it is a representation of what was created. So therefore, if you're creating a secret, it's going to end up in that state. There are ways in plans and in Terraform to kind of hide the values so they're not output to the logs, which is another area that people could focus on to grab those secrets. But the state will have secrets in it because it needs to be able to manage those resources. So you have to be careful with where it's stored. And so this is a GitHub issue that was opened, I think, in 2014, where someone was basically asking HashiCorp, how do I manage secrets in state? And this, I just checked this thread, and as of 20 hours ago, probably about 24 hours at this point, they are still updating this thread, and it's from 2014. So we're getting on 10 years of this discussion about how should we keep secrets in state, and it's still actively going. So it's an issue that people are still struggling with, especially if they're using Terraform open source, but it applies also if you use some of their enterprise tools as well. So kind of pivoting on to other aspects of Terraform. So everything in Terraform, it's just a configuration tool that you write your code and it interprets it into what's going to be built. The providers are the piece that really interact with your different, cloud providers or different systems. It doesn't have to be just AWS or Azure or GCP. There's a lot of different Terraform providers that you can use to interact with infrastructure. So don't think of it as just a cloud configuration tool. There's more than that. But the flip side of that is these are just a handful of the providers that HashiCorp alone, HashiCorp who creates Terraform alone releases. So you can see they have all the typical ones: AWS, Azure, Kubernetes, their own internal services, their products, Console, Vault, things like that. But there are hundreds of providers out there that it's another third-party library that we're utilizing in our code that we don't always have full insight into. The providers are usually very large because they replicate the API from the cloud provider or whatever service you're using. So they're very large. Most people don't review all provider code before using it. And there's some people who use, it's a typical issue with open source libraries, whether they're application or infrastructure libraries, but people use open source providers to do certain things or to interact with certain services. So this adds another layer of complexity when it comes to securing Terraform, where it's also an area that you can both abuse as a malicious internal user, but also as an external user if you could update provider configurations, provider code to harvest credentials or create something in people's environments because it's in the provider config, which they're probably not going to look at. So it's one other area you have to think about when it comes to Terraform security, is the fact that we're relying on this this huge ecosystem of open source code, which is great that it's open source, but that doesn't mean people are reviewing it and finding all the security issues. So it's one more aspect of this. And I wanted to talk a little bit, this is an API security conference, so obviously I wanted to touch on some of the APIs, but Terraform itself when you're running it locally, there's not an API because it's just a binary running in your, Jenkins or whatever CI/CD tool you might be using. But when you utilize things like Terraform Cloud or Terraform Enterprise internally, then you introduce quite a few APIs, and those can be pretty powerful. As I mentioned, when it comes to state, if someone can use the APIs to update state or update environmental variables in your Terraform instance, they can do a lot of damage. The thing that always worries me and keeps me up at night with Terraform implementations is someone importing all the RDS instances in a production environment and then just using Terraform to destroy them all. That's a pretty worst case scenario, but even accidentally importing the wrong resources could lead to things getting modified or deleted. So the APIs that underlie Terraform are very powerful and also have to be protected because Terraform itself is such a powerful tool. So and there are various access levels in the Terraform API, so you can restrict those to a certain degree, but it's another thing we have to think about when it comes to the whole ecosystem of Terraform and how to lock it down. So my point with this kind of preamble about introducing Terraform is it's a very powerful tool. It's very easy to get going, but it can be very complex to configure in a secure way. And you have to think about the whole threat model of how you implement an infrastructure as code tool like Terraform. So it's for use by a competent person only. So diving into some of the ways that you can abuse Terraform, we'll go over some of these techniques. This is just a handful of ways that we've discovered to do various kind of remote code execution or data exfiltration or data gathering activities with Terraform. This is a very small list of things you can do. The bad thing about this is these are all pretty much built into Terraform itself, so this isn't relying on a third-party provider. These are all Terraform provided functions, so this isn't something that's easy to kind of remove from a Terraform implementation because it's not a third-party service. So we'll go over some of these. So the first one we'll talk about remote exec. The name kind of says it all, but Terraform and HashiCorp is pretty straightforward with this. They are not a configuration management for hosts tool. So they're not an Ansible, they're not a Bash scripting language. They're not meant for that type of host level configuration. There's a lot of good tools out there and tools that you can also use in a secure way and use some of the same security controls we're going to talk about to control those. But Terraform does not bill itself as a host configuration tool. That said, there are ways with Terraform to actually do some of these things. So remote exec is one of those where it can be used to run scripts on hosts after provisioning. So you set up your EC2 and then you can run scripts. This isn't anti-pattern. HashiCorp does not recommend doing it this way. It's kind of a last choice if you can't use something like Ansible or other scripting languages to do this. And the other big issue with this is you're now mixing code with infrastructure deployments. And by code, I mean things like Python scripts or Bash or whatever your choice of scripting language is. Perl is always a great choice. I grew up on Perl, so can't hate on it too much. But it introduces those languages into an infrastructure as code environment, and that's two different levels of code you have to understand and secure. So it adds a lot more complexity. So, and this is from the Terraform documentation. They also add a considerable amount of complexity and uncertainty to Terraform usage. So the general recommendation is to not use them. And so what can you do with something like remote exec? This is an example, again, of creating an AWS instance. We're just creating an EC2. We have a connection type. And then at the bottom, we have our provisioner. Remote exec is considered a provisioner, not a provider, which is called remote exec. And then in this case, we're running a netcat command to shell out back to an external IP that would give someone a shell into the server we just set up. So what is the use case for this? If an attacker didn't have access to an actual server, but they were able to run Terraform, they got onto a developer's machine that had access to deploy Terraform, or they got onto a server running Terraform, something like that. This could be a great way to basically establish persistence in your production environment if you were able to push this out through your Terraform pipeline to whichever environment, production or whatever they ended up choosing. But this is this goes from someone has access to Terraform to someone an external user has access to your production environment. So this is definitely a pretty bad practice to use this, obviously, and this is the kind of thing you'd want to check for. And again, this is mixing code with infrastructure as code. So we're looking at bash scripting mixed in with infrastructure as code. So it's harder to catch these kind of things with some of the tooling, but I'll show you some ways that you can kind of prevent this use case being used. So another one that's built in is called vocal exec, which just like remote exec, it's kind of straightforward, but instead of it being run on the remote host that's being created, this is running on the Terraform host that Terraform is running from. If you, based on what I was talking about during the challenges piece, remember Terraform is often given very highly privileged, or your CI/CD is often given highly privileged rights into your cloud or on-prem infrastructure. So someone being able to run code on the machine that has those rights is an issue. There's a lot of different ways that this can be abused. And again, this is another note from HashiCorp themselves. Important, use provisioners as a last resort. There are better alternatives for most situations. And so even they give you this option, but they say, don't use it, basically. Use something like Ansible to do your configuration. But really, people shouldn't be running code on your provisioning server. They should only be running code on provisioned servers that are for them. So again, this is a simple example, but if anyone's familiar with the EC2 metadata service, it's a loopback address on every EC2 and other services that basically allows the EC2 to assume a role in AWS. And there's been some famous hacks due to the metadata service, and AWS has released some controls, but those controls aren't widely adopted kind of across the board. There's a lot of people who still use the kind of insecure configuration with this. But we've tested this in various clients where if you can use local exec to run on the Terraform server, even if that's Terraform Enterprise, which itself utilizes servers to run Terraform implementations, you can call the metadata service, and if you know a little bit of information about the infrastructure, you can get the IAM credentials, the STS credentials, the short-lived credentials from that service, and you could do something like just dump it in the Terraform output so you can see it in your run, which would be exposed in your Terraform Enterprise or your Jenkins output, or you could do something like curling that output out to a remote system. So if someone was able to introduce this, if they got GitHub access to a repo that had access to, or that ran Terraform, someone could update this, have it run when Terraform runs, and exfil those security credentials. Then they could use those to get back into the environment to do other attacks. So again, local exec, just like remote exec, is not it's not a best practice. There's better ways to do these kinds of things, and you shouldn't be mixing infrastructure as code with scripting and regular code. So kind of talking about the first security control, SemGrep is it's become a more popular security tool. It's open source, it's free, and really it's kind of like what its name says. It's better grep. There's much more to it, but at the end of the day, it's a pattern matching tool. The great thing about it is it's very easy to write rules with SemGrep. It's easy to integrate it with pipelines. It's pretty fast compared to a lot of static analysis tools that are out there. And there are quite a few open source rule sets you can use kind of out of the gate, so you don't have to build them all yourself. So it's a great tool to do not just infrastructure as code security, but also application security, static analysis in your pipeline. So it's just a great tool to introduce in a few different areas. So this is an example of how you can use SemGrep to write very simple rules to check for things like what we just talked about. So you can see on the left, you have it's a simple YAML file for SemGrep where you are defining a pattern. In this case, we're looking for a provisioner, any provisioner, and we're calling out an error if it's found. And this is the SemGrep playground where you can test out rules against sample code. And you can see in the example code on the right that it finds a provisioner, in this case local exec, and flags that. So the idea would be you can implement SemGrep in your GitHub Actions, in your CI/CD pipeline, wherever you do your either code quality or your unit testing or hopefully your security testing. You can integrate it, and you can block people from using things like provisioners with simple rule sets like this. So it's a great way to get started with kind of guarding against some of the things that I've talked about so far. So the other thing that is great about Terraform, which is also a bad thing, and I've kind of touched on this before, but there are a lot of different providers that can call outside services. So one of the things that you can do with Terraform is call things like AWS SSM parameter store. There's a little bit of support for HTTP, and so you can in Terraform call different services as part of your code. You can also pull from the current state of the AWS environment, which is all well and good when you're trying to make updates, but it's not a great thing if you have secrets, if you have SSM parameters that might be sensitive. So Terraform is a great way to gather some of that data as well for attackers. So it's another area that you have to think about with Terraform. So again, you're using the EC2 example, but there's a data resource called HTTP that is basically during the plan time, you run it and it will go and access whatever kind of endpoint you want. So data resources in Terraform are usually run during the plan time to gather the data that's used in the apply. So you can think of it as in go out and get values from SSM, go out and get values from some HTTP endpoint, and then that'll get added to the plan, and that may be used during the apply. So you can use the HTTP data source, which is just an HTTP call, to gather data that gets output in in this case, we're outputting, again, the EC2 metadata endpoint, the STS credentials. You can use that to basically go out and grab those temporary credentials. And this is what you'd see when you run a Terraform plan. This is running locally on an EC2, not running through Terraform Cloud. But when you run the Terraform plan, it's going to go out, it's going to make that data call, and then it's going to dump out that information. And in the middle, you can see you have your secret access key, you have your STS token, and this would basically allow you to assume this role that the EC2 is given, and then you can do whatever you want with it. So obviously that's a pretty bad thing to be able to do. There's a lot of other abuse cases for data lookups with Terraform. Like I mentioned, if you use SSM parameters, if you use Secrets Manager in AWS, you can also use it to pull that data in at plan time. Then you're really relying on your tooling and IAM to prevent people from doing that. There's also a couple interesting use cases, like Windows EC2 has a get password data call, so you can use that to also gather the EC2 password. And there's just whatever data resources you can think of in AWS, there's a way to abuse those through Terraform. So it's another area we have to think about when we're kind of threat modeling and building our controls for Terraform, is how do we prevent data calls like this. So again, going back to SumGrep, it's very easy to write a rule that prevents a user from doing this. So again, we define a pattern, data, HTTP, and then we just allow anything after that. But this can get much more complex. I'm showing very simple examples of SumGrep. You can get much more complex. You can do multiple patterns. You can do taint tracking. You can do a lot of different things in SumGrep. These are very simple examples just to get people's mind kind of in the game for how you can use SumGrep for this kind of thing. So you'd run this in the CI/CD pipeline before a Terraform plan is run to make sure that no one's using the HTTP data call. And as you can see, again, this is in the SumGrep playground. It's getting caught. So in theory, if this is a CI/CD pipeline, it would get blocked. So another example of how you can use this is there's something called external data. And it's a very confusing term because you'd think external data is just data that's outside of Terraform. But in actuality, it's a way that you can use a data call to run code. So it basically gets passed to Terraform as some kind of program and some kind of input. So in this example, we're running a Python script called exfilldata, and we're passing in a data call from Secrets Manager. So in theory, you can have a Python script that gets that data that's pulled in at runtime and then is exfilled out. So it's another way through Terraform to gather data or to run kind of arbitrary code in your Terraform pipeline. So another area you have to block. So I've showed some very basic examples of how you can use things like SumGrep to do security testing, but they're, at the end of the day, it's pattern matching. You can get very complex, but it is pattern matching. We're missing things like resource-specific checks. We're missing things like full coding logic, if else, logical statements, and there's ors, all those kinds of things. So we want to be able to do more in-depth IAC security controls. So there's a couple options. There's more than this, but there's a couple options that I'm familiar with. HashiCorp Sentinel and then OPA. So HashiCorp Sentinel is a commercial tool from HashiCorp that's built into Terraform Enterprise or Terraform Cloud. And OPA is the open policy agent, which it's not a Terraform specific tool. It's actually used for, it can be used for just about anything. It can be used for authorization checks. It can be used for coding checks. But the two are very similar when it comes to Terraform and kind of how they work. And there's advantages and disadvantages to both. I'm going to focus on Sentinel because that's what I'm most familiar with. So some of the benefits of it, and I'm definitely not trying to sell you on Terraform Cloud. It's just the environment I'm the most familiar with. But its policy is code. We've kind of talked about that. You can pull in external information. It's very fine-grained. It's embedded into Terraform Cloud or Enterprise. It is multi-cloud, so you can write rules against any cloud. So there's some good integrations between Terraform and Sentinel. So what do these rules look like? So now we've gotten to actual code, not just pattern matching, but actual code. So in this simple example, we have importing the TF plan. We've kind of talked about that. And we're running basically a find resources on that plan, and we're looking for any AWS instance. And then we have a list of allowed instance types. So that's the size of the EC2. And we have a filter that's basically going to say, are these EC2 instances, is there instance type in the allowed list? If not, then we'll fail. So it's still very simple overall. It's not overly complex code, and a lot of these rules can be very simple in this way that you're just checking a simple value for, is it encryption? Encryption is true, or the right subnet is being used, or the right naming convention is being used. It's not, they don't have to be overly complex any more so than SemGrep does, but it does give you a lot of benefits of giving you a full coding language to use instead of just simple pattern matching. And here's a more complex example where we're enforcing a role, but we're, again, we're pulling from the plan. We're running a validation of any role. Any role should match the role we define at the top for the plan that we're looking at. So there are ways you can use these tools to basically enforce what role a resource can be, what role a resource can assume or what it can use, which, a lot of larger companies are very big into vertical segmentation, which is, my app should not talk to your app and vice versa. And so one of the ways you do that is by enforcing things like what IAM roles your resources can assume. So this can be, this is a slightly more complex example, but it's still relatively straightforward to kind of understand. And with helper functions and some customization, it's really not that hard to write more complex Sentinel rules to enforce these kinds of things. So I touched on this early on, but one of the issues we have with Terraform is when we're talking about SemGrep can be used both before and after the plan, but generally it's used before the plan because it's used on actual Terraform, not on the Terraform plan. Whereas something like OPA or Sentinel is run on the actual plan. The reason being, after you do the plan, you know what you're going to create, you know what you're going to update, or you know what you're going to destroy. You have more in-depth information about that resource that you're modifying. But as I mentioned, there are things that aren't known about the environment until they are actually created. So they might not be known at the plan time. They might only be known at after the apply has been done. So that becomes an issue when we talk about security controls, because if you want something like Sentinel to enforce a value, it's going to look through your plan. It's going to say, hey, give me the EC2 instance type. But if the EC2 instance type isn't known until after the apply, it's going to say, okay, there's nothing to check here, so I'm moving on. That's a big issue because obviously if you can make something an after unknown, and there are ways to do that, you're gonna basically skip a security check. Some of the ways you can do that are creating those dependencies where the value you're trying to make after unknown is a value that's coming from a different resource. So if it's something that's being created like an ARN, if it's being created at the apply time, you won't have that in your plan, so you can't run a security check against it. So that's a pretty big issue when it comes to these plan-based tools, and it's something that HashiCorp recognizes too. And OPA would be similar. So you actually have to do explicit checking for things like after unknown. You have to check to see if the value you're working with is after unknown, and for the most part you have to say do not allow after unknowns. This is something that's come up in large implementations of these tools where you have to check for these kinds of things and just not allow them, because if a malicious user, either internal or someone who gets access to Terraform, is able to create these after unknowns, you can basically bypass some of these security checks. So that was a lot of saying what is wrong with Terraform and ways you can abuse it. So how do we solve some of these issues? I think like anything that you're trying to secure, there's a lot of layers to how you solve these things. You don't just slap on one tool, no matter what a vendor tells you, and say, we're good to go with just this one thing. There's no silver bullet for any of these things. So some of the things that we've done in these implementations are build kind of different layers of defenses. So the big one is IAM. How do we use IAM to guardrail these things? But there's, the patterns you build. Obviously, we talked about doing automated code review, so that's a big piece of it too, using something like SemGrep or OPA or Sentinel to do the code review and the plan security enforcement. locking down your Terraform environment is very important, especially when you talk about those APIs. Segmenting deployments, having your test dev and production environments being separate, and then monitoring is definitely important. So for IAM, I think this is one of the big pieces that people need to focus on, which is building, sort of common sense IAM policies for the thing that you're doing. If an EC2 is only being used to run some application, does it need access to all of your S3 buckets? Probably not. If Terraform is just setting up 3 services, does it need access? Are you going to give it the admin access role or policy? You probably shouldn't. Limit the privileges that you give these tools, and that you give the end services that the tools provision as much as possible, so that IAM can be your kind of first line guardrail against these kind of things. And there's good ways in, especially in AWS IAM, where you can use conditionals to say, this role can only be used on my EC2 or within this VPC. And they're kind of improving the ways you can do that. So you can lock down, say, your Terraform role to one machine, which is a good best practice to kind of limit the use of that overly powerful role. And then obviously you have to monitor changes. That means doing consistent reviews of what your policies look like, limiting who has access to change those, and then alerting when someone does change those things. Patterns. I think this is a big piece that people don't focus on as much when it comes to cloud adoption, is how do we want to adopt the cloud? You say, I want to have an EC2, I want to have an RDS, I want to have S3, I want to have CloudFront, but what does my pattern for that look like? How do app teams move into using these resources? What is the IAM kind of structure look like? What does the networking structure look like? We have to define those patterns for how we use these services. That can even be down to what the naming conventions for the different parts of the resources are, and documenting those guardrails to say, okay, we're adopting a new service, we need to have these guardrails in place, and then we build those in SemGrep or in Sentinel or whatever it ends up being. And then also minimizing the IAM rights as much as possible. And then you need to harden your services. So if you're adopting a new service, you need to go through the configuration and harden those things. So make sure, encryption's turned on, make sure that it's properly segmented, make sure, you have all your different settings for those services set correctly. And that's really easy when you have those things documented. Then you can build the infrastructure as code testing on top of it. It's really straightforward to do that for the most part when adding new services. And then we talked about code review quite a bit, but doing code review in your pipeline, so having things like SemGrep, or you could even have just regex, it doesn't have to be that complex, but having code review in your pipeline, both before the plan and in the plan, is the best practice, and enforcing also standards for how you write code as well. I don't think it's realistic to have a human review every piece of Terraform before it goes out the door. I don't think anyone has the security team that's large enough for that, so we have to automate these solutions and put it into pipelines in order to enforce it. Then I mentioned monitoring. We should be monitoring the IAM, the policies and roles for Terraform itself. We should also be looking at how policies and roles are changing for the resources that we provision. And we should be monitoring the Terraform environment itself. So we should treat it as a very powerful tool that needs to have, it's segmented, and if people access the environment, we should know about it. If people's rights in Terraform Cloud are changed, we should know about it, all those kinds of things. So kind of the takeaways from this are, Terraform is a very powerful tool, and I definitely recommend people adopt it or similar tools to standardize how they build out their cloud infrastructure, and also centralize where they build out their cloud infrastructure. It has great, very high signal and very effective security integration points. We kind of talked about those in terms of being able to write code, write rules against infrastructure as code. So writing rules against your Terraform, but the implementation must be well thought out. You have to have multiple layers of controls, and you have to monitor it very closely. So thanks for anyone who's still listening. It's great talking about this, and if there are any questions, I think the chat is open. And Elizabeth, are there any questions?
Curious if this is applicable to CloudFormation and other IAC tools.
Yeah, SemGrep can be. Sentinel is a Terraform specific tool, but there's a lot of other tools that we've used elsewhere to build out some more things. I don't know if there's OPA support for CloudFormation yet. That's actually something I should find out. But even regex can be used on things like CloudFormation. But there's different tools. Linters especially have been abused to do kind of what we're trying to do here with Sentinel. So
as you mentioned, right now budgets are tight, teams are tight, small but mighty. How would somebody go about implementing these types of controls?
I think the great thing is a lot of the tools are open source. So SemGrep is open source. You can write your own rules, and again, it's very quick to get going. So if you have a pipeline, I would suggest figuring out your kind of highest risk areas, whether that's your services, whether that's IAM or that's networking, and focus on building your patterns for how you adopt those, and then build your SemGrep rules around that. So define your networking standard, define security group rules, define how routing should be done, and write some grep rules around that, integrate it into your pipeline, and then you have a free tool running that enforces those kinds of things. Same thing for IAM, look for service star, look for S3 star, and integrate those kind of tools. You don't have to, boil the ocean with this kind of implementation. You can start small and build. So I think that's the great thing about it, is it's cheap and easy to start. It gets more expensive over time. So, well, I think that is my time. So thanks again for listening. And if you want to reach out to me, I'm Mike@cloudsecuritypartners.com and McCabe615 on Twitter.